Welcome back my dear friends and students. This is the course on multi-criteria decision making, and which is a course for 12 weeks spread over 60 lectures, and each week we have 5 lectures, each lecture being for half an hour. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you remember, in the 43rd lecture we were discussing about the Topsis method, and time and again I mentioned about the concept of PIS, NIS, how you can find out the distance, how you can divide the criteria into 2 sets, and based on that you can have the negative distance, positive distance, and based on the negative distance and positive distance how you can rank them. The discussion also came up that, and it was very obvious that when you are trying to rank them, you need to find out that how far it is from the positive, how far it is negative. The distance measured from the negative one is 0, that means it is not at all preferred, and the distance measured from the positive is 0, it is definitely preferred. So, based on that, the positive one, negative one, you found out the ranking for A1, A2, A3, A4, which was the alternatives. And why it was done? Because it was a double check that both from the side of getting the benefits and trying to reduce the disbenefits. I am using the word reducing the disbenefit. So, benefit should increase, disbenefit should decrease. So, both from this point of views, the alternatives were perfectly balanced. Balanced in the sense the ranking, there was no dichotomy, there was no confusion. But we can have a situation or situations where these dichotomies can arise, where when you are taking the decision on the benefits and the disbenefits, the decisions can vary. We will see that. Now, having discussed Topsis, we will consider the next method, which would be our discussion for this 44th lecture. As usual, the main umbrella under which we are discussing is multi-criteria decision making. We have already gone through multi-objective concepts using different linear programming, non-linear programming, integer programming, considered both the concepts how you try to find out the optimized values for two functions and more than 2 functions, and and 3 functions as usual, and in one case we did discuss about how they would look in the 3-dimension one, and in two cases we discussed how they would look in the 2-dimension case. It was easy for me to explain. Now, we have started for the last few lectures about the multi-attribute, the non-parametric methods. Having finished Topsis, we will consider the ELECTRE method. The ELECTRE method, even though it was mentioned in the last class, the discussion went on. So, that means I could not start it in the 43rd lecture. So, the coverage would be starting on elimination and choice translation concept, which is known as the ELECTRE. Now, the concept of elimination and choice translation reality is basically a French word, and it was basically found out by Roy in 1990, and it is one of the MCDM tools based on the concept of outranking. Now, if you do remember, in the Topsis method is basically how they are close to the ideal best and the worst. The concept of the outranking would also be used in this manner as we have considered in Topsis method, but here we will be considering the concept of ideal solutions and the non-ideal solutions in a different way, but the ideas remain the same. Now, in the course of time, generally different variants of ELECTRE method came, which were known as ELECTRE 1, 2, 3, 4, tri and IS, but we will only stick to the simple method in trying to understand the ELECTRE method. Now, the ELECTRE method which we will discuss here would be a little bit lengthy in the sense that the ideas of some loss functions would also be covered in the ELECTRE method. Now, the question may immediately turn up from your side or from the student side, couldn't we have done the concept of the loss functions for the Topsis method, or can't we use the concept of the loss function in the other method? The answer is yes, we can do it. But rather than trying to repeat it for each method, I will only concentrate in the ELECTRE method, and it can be replicated in the other concepts of non-parametric methods or outranking methods accordingly. So, there are different texts, and the texts have been given in the slide in the first time when we are discussing. And these are very recent concepts which are used in big projects trying to analyze where non-parametric methods are there, where decisions are not very objective, they are subjective. So, for our simple understanding, as I said few minutes back, we will consider the ELECTRE 1 method and a variant of the same. The first question which will come up when you are doing the ELECTRE method is, what do you consider as the concept of outranking? So, the outranking would basically consider, and I have already mentioned in a different way when we are doing the Topsis method, outranking would be the concept that on the positive front, what are the good points or what are the good qualities the alternatives has, and on the negative points, what are the disbenefit the alternatives has. Like for buying the house, price more is definitely not required, we want to lower the price. Maintenance cost for the house definitely required, not required, we want to lower it. But if the number of rooms are high and the same price is good, safety is high, good, locality is good, it is good, it is nearer to schools, nearer to shopping centers, nearer to hospitals, nearer to the transportation, all are good. So, we will basically consider outranking in this concept, try to divide them into the positive and the negative benefits. So, stated simply, the method of outranking is the idea in which one compares one decision of the alternatives against the other based on some set principles. Now, immediately the question which would come up is that what are the set principles? Do we know it? Yes, we have already considered that if I am trying to analyze buying the house, there were 11 different concepts based on which the decision was taken. So, those would be the criteria based on which the outranking would be analyzed for each alternative. Now, remember, one point was mentioned from my side time and again, at least twice in the discussion when we are doing, for all these non-parametric methods, the ideas of trying to compare the alternatives based on the criteria can be done only on a one-to-one basis. That means, I cannot collectively consider all the criteria and do the ranking for two alternatives. So, I will consider one at a time and then combine them based on the weights. Now, coming back to the concept of the weights, would the ideas of the weights will also be replicated? Yes, they will be replicated. Would the concept of utility function will also be replicated? Yes, they will be replicated, and we will see that. Only the last stage of how you do the outranking is to be done. Now, continue reading this. In doing so, one assures that the end of this pairwise ranking, pairwise ranking for the alternatives, we have a unique ranking system amongst all the decisions and alternatives based on which we can take the decision in a much more objective manner. Obviously, subjectivity is there, but our analysis will try to make it as objective as possible. Now, here also the excuse me, the background story is the same. We will have basically A as the vector which consists of A1 to AM number of alternatives. C vector is basically C1 to Cn as the number of criterias, and we will try to analyze them accordingly. When we try to basically accomplish, we will basically do the same concept of the ranking ideas which I have been doing is as follows. So, if there are two alternatives, consider this as A, I should use the black one, A1 and A2, any arbitrary in the set A. So, you can basically have A1 is better. I am using colors, red does not mean bad or worse, I am just using different colors to maintain them. A1 is better, which is I get the benefit, and on the disbenefit side is lower for A1. If I consider equality, even though I use equality sign, just generally it will be utilized like this. So, that means both balancing the benefit and the disbenefit, benefit positive, disbenefit should be on the negative side, they balance each other. And the third one is basically A2 is better than A1. Now, this red one and the green one may try to give you the same ideas. So, what do we mean by the red and the blue, red and the green, which is greater than sign and less than sign? So, it means that consider A1 and A2 is there. In case 1, I take A1 and in case 2, I take A2. Now, when I am taking the decision A1, both the benefits of A1 are coming as well as the disbenefits of A1 are also coming. When I take A2 in case 2, I am getting the benefits of A2 as well as getting the disbenefits of A2 also. To expand this concept, so when I take case 1, is remember this, I am getting the benefits of A1, I am getting the disbenefits of A1, I am not getting the benefits of A2 and I am also not getting the disbenefits of A2. That means, if I have taken A1. In the case when I am taking A2 and not A1, what are the ideas? Ideas are, I am getting the benefit of A2, getting the disbenefit of A2, not getting the benefit of A1 and also not getting the disbenefit of A1. So, if I consider these 4 combinations for case 1 and case 2, there are basically 2 positive and 2 negative. What are the positives? In case 1 positive is benefit of A1. What is the other benefit or positive one? Is basically not getting the disbenefits of A2. And what are the negative? Negative are getting the disbenefit of A1 and not getting the benefit of A2. So, if I go to case 2, the answer would be exactly the same, but trying to basically analyze the problem from A2 side. So, remember that what I said, when you are taking A1 or A2, you are getting the disbenefit and benefit in a set. So, the 2 sets would be benefits and 2 sets would be non-benefits or the disbenefits. So, obviously, when you try to analyze that, the ranking concepts would basically be a collective of all these things. So, this idea which I just mentioned, benefit disbenefit, was also there in some way when we consider the PIS distance and the NIS distance accordingly. So, one advantage of the ELECTRE method is the fact that the final result when presented to the decision maker. So, the decision maker makes the decision, presents it in front of the whole set of people who will have an analysis of this tool and take the decision. It is easier for him or her to take the final viewpoint rather than what he or she would have taken with only A1 or only A2. So, A1 and A2 both being given is that case where disbenefit and benefit all would be analyzed. Because in that case it may be only if you consider A1, then you are only going to judge all the alternatives being m in number based on either the benefit or the disbenefit. But if you give it collectively, both the sets of disbenefit and benefit would be considered when you basically do the outranking for all the alternatives. Now, expanding on that, in case if the ith alternative, by the way, when I am considering the alternatives, these are what the decision you want to take, like buying the house, buying the type of car or taking admission in one college, and what would the criteria would be. I am sorry, I am repeating these examples time and again, please bear with me. The criteria would be for buying the house would be the price, maintainability, maintenance cost, locality, safety, nearer to schools, colleges, hospitals, shopping center, family members being there. So, all these can be the criteria. For the car, price, maintenance, what is the mileage, what is the safety features, boot space, and so on and so forth. For the college, it can be what is the rigor of the course, what is the type of internship the student get, what is the final placement, what is cost of that, what is the ranking of the college, what are different type of programs which are there. So, these would be the criteria. So, in case of the ith alternative, let me continue reading it. AI outranks jth alternative. By the way, I and j I am considering. So, obviously, actually j is basically for the criteria, but for our discussion we are considering I and j are the index based on which I measure the alternatives. Ith alternative AI outranks jth alternative AJ, then we denote this relationship AI outranks AJ. So, if it is the other way around, so AI and AJ would get flipped, which means that, and this is important, that the risk of the loss whatever one would like to say, or the benefit or the disbenefit. So, risk and loss I basically mean the disbenefit for AI is not as much as AJ, or AI is as good at AJ and not as worse than AJ. So, I am trying to look at the picture as I said few minutes back, both from the benefit and the disbenefit side. So, ideally would be what? I get all the benefits and I also then do not get any disbenefit, that means disbenefits set of the overall point is 0, which cannot be. Now, how one decides the so called relative ranking between the alternatives A, I and J is a matter and which is of prime importance for us. It is also noteworthy to mention that the collective cumulative effects of the n number of criterias or the m number of criterias would come into play. ELECTRE ranking is non-transitive. It means that if here it is important, if AI is better than AJ and AJ is better than AK, it would not mean AI is better than AK. But if you consider this transitivity property from the real line, it is very simple to understand that would be true. In the sense, if I have the real line and if the points are, I will mark in green, this is 1, this is I am taking the real line means going from my side to the right is positive higher and this is 3. So, if I say 3 is greater than 2 and 2 is greater than 1, so then obviously 3 is greater than 1. But when I am say for example, analyzing quality attribute, then this dichotomy may occur where transitivity property may not hold, which means that if I have or if I find out the ranking and I put this ranking as, say for example, ranking means this 1, 2, 3 are not to be confused with A1, A2, A3 which I am not writing. So, say for example, I write A1, A2, A3 not on the real line, just like this, which may be A1 is better than A2, A2 is better than A3, but it may be possible that rather than A1 being better than A3, it can be A3 is better than A1, and here is what the discussion is all about, outranking. In ELECTRE method, if you remember in the Topsis method what we did, PIS and NIS. In the ELECTRE method, we will use the concept of concordance and discordance. PIS was positive distance good, NIS was negative distance bad. Here we are trying to basically use a different concept of concordance, agreement, discordance, disagreement. So, in ELECTRE one uses the concept of discordance and unconcordance and discordance, which is a sort of level of liking, disliking, which I just mentioned, respectively which one has when comparing two criteria based on the decision maker's utility or the net worth which he or she is going to place. So, if we say that if we like AI with respect to AJ, when one chooses AI in place of AJ, then one assigns some scores or points or quality points which are positive and quantifies this level of liking in the concordance level, in the positive level. On the same basis, if due to some reason one is forced to choose AI with respect to AJ, then the level of disliking is objectively summarized in the discordance set. Now, the question may immediately come up that when I am taking A1 with respect to A2, isn't it possible that I have some of the criteria which are positive and some of the criteria which are negative? Yes, it is possible. Like, to give an example, I am talking verbally, I will come to that when you consider the house price being high, maintenance cost being very high, which is basically discord, it will technically go into the discordance set which was in the NIS concept. Now, when I am considering the positive, like room number of rooms is more, safety features is there, family members nearby, bus stop nearby, schools nearby, hospitals nearby. So, they would be in the concordance set. To deal with this outranking relationship by using pairwise comparison, under each of these criteria we do it separately. So, you take criteria 1, do the ranking for A1, A2, do take the second criteria, do the ranking between A1 and A2 and do it accordingly. Then you take criteria 1, do it for A1, A3, then take criteria 2, do it for A1, A3 and continue in this way. The outranking between two alternatives A I and A j, which we have already seen, is denoted by A I is better than A j, which generally means that even if the ith alternative is not dominating the jth one, yet the decision maker can choose ith one, because the bundle of positive things, concordance, is more than the discordance concept. Alternatives are dominated if there is other alternatives which excel them in one or more of the criteria and equals in the remaining one. So, they can be different alternatives, and if there are 10 alternatives, 9 of them are equal benefits collectively, but one of them for the first alternative for criteria 1 is much better than the same first criteria for the second alternative. So, obviously, the ranking would definitely be more tilted towards A1. One important thing, when I am considering the outranking concept and when we write the function in the some matching index like this, and here it is important to note down, even though it is written as GIAJ, actually the ideas would be done accordingly like this. So, I need to find out a specific threshold. Based on that, I will need to find out the concordance and discordance. Now, the concordance and discordance concept should be remembered is based on this. So, let me draw the line which will be coming up. So, this is the real line. Now, when I consider the concordance and discordance concept, so consider my liking if I take A1 with respect to A2 is, say for example, plus 2, whatever the unit is plus 2, that means I like. But it does not mean that when I take A2 with respect to A1, the value is minus 2, no, because this concordance concept and discordance concept and the function based on which we are trying to basically analyze A1 and A2 is not a symmetric function. So, if I am trying to analyze or trying to understand the overall concordance concept and the discordance concept or the liking disliking as a matrix, then it is not a symmetric matrix, because in the sense that if I take A1 and not A2 or take A2 not A1, the points obviously they can be different, and even if they are same, it does not mean they are basically positive and negative. We will consider that in the concept of the DL line accordingly. One should specify the threshold which depends on the decision maker choice. Concept of utility function is important. The decision maker assigns weights or importance, same way we have assigned weights, important factors to the criteria, and this is done in order to express one preference to show the relative importance. This also comes from the fact that the utility function or the net value concept of any decision maker process is an important driving force for the choices and how the rankings are made. The method is convenient when there are few criteria and a large number of alternatives, because you have to consider this ELECTRE method, and as I said, I will consider two different concepts of ELECTRE method. The line which I have drawn about the ranking of better than worse than will be coming up later on, but first let me just specify very simply here. So, what we are trying to find out is based on the fact that what is the distance measure onto the right hand side and the left hand side of taking the decision and not taking the decision. Now, if you see this line which I have drawn is equidistant. So, if I basically mark point, see for example, x here, x has no meaning, I am just putting x1 here, and if I put y1 here and y2 here, the distance measure from x1 to y1 from the right hand on to the right hand side from my side, from your side it will be left. So, it is on the right hand side, the distance between x1 and y1 and the distance between x1 and y2 are equidistant, which means they are equally dispersed, but the answer would be in many of the cases it may not be true. Now, few of the concepts of the distance measures which I did mention in the Topsis method, the simple distance measure, but I will just elaborate them accordingly. The Euclidean distance, and they are all based on the same formula of the LP norm or LP distance. The Euclidean distance between two vector points x, where x is a vector from x1 to xn and y is equal to y1 to yn, is given by this formula which we all know. That means, finding out the difference between x 1, y 1, squaring up, then adding it the difference between x 2 and y 2, then squaring up and doing it for all the n number of points which are there, and adding up and then finding out the square root. So, in the case when it is the L1 norm, I need to find out the mod, and when it is basically sum of the mods, when I want to find out the L infinity with the max. The L1 norm, as we know, is the Manhattan distance between vector points, and it is given by the mod difference and the sum. Why Manhattan norm? It looks like, if you look at New York from top, the roads are all running parallel and perpendicular to each other. That is why we say that it is a mod based on the Manhattan distance. There are other distance also. Consider between two random vectors given x and y are in the n dimensional and S is the covariance matrix, we also can find out the Mahalanobis distance, which we would not be mentioning, but I just thought I will mention different type of measures which are used, distance measures. Another distance measure which is used is the Hamming distance. It is used in case of many biological studies, is the distance between vectors of points, and where the vectors are from x 1 to x n for x vector and y 1 to y n for y vector, is the number of positions at which the corresponding values are different. So, you count down the numbers and then basically find out the Hamming distance. The L infinity norm is given two vectors x and y in n dimension, it is given by the max, and the general concept of the LP norm is given by this concept, which is mod of the sum of the mod of the difference between x i's and y i's to the power p, and then finding out after the sum you find out the 1 by pth power. So, now if you put p as 2 is basically the L2 norm which you have already obtained. So, I have considered few examples of the distance, and I will tell you why they would be much more relevant as we come up. So, I will take few minutes to discuss the distance concept. If there are 2 points x and y, and in the 3 dimensional case, and they are the points are x 1, x 2, x 3 are 2, minus 5, 20, and y 1, y 2, y 3 are 12, 15, 0. Then based on the L1 norm, where it is basically sum of the mods, it comes out to 54. This is important. Why I am mentioning the values is important. If I find out the L2 norm, put in them the formula, the value comes out to be 31.55. And if I find out the L infinity norm, the value comes out to be 20. Very interestingly, the values are decreasing from L1 to L infinity. So, can we have some visual flavor of that? So, let us do it. So, I have just plotted the values of p. P is 1, 2, 3, 4 till infinity. So, and depending on when p is 2, you have the L2. So, when I measure them along the x axis is 99, it will go till infinity, and when I measure the distance for these 3 points for x and y which are in the 3 dimensional state, the norms of the distance very interestingly looks like this. So, obviously, there is a difference in values as p increases, but just for information I have drawn the values. So, the last value which you have for infinity was basically 20, the value which you will have basically for L1 was 54, yes, it was 54 and it was 20, and the last and the first value, second value which was for L2 was 31.5. So, it is somewhere here. So, I have not marked the points, but this is the general characteristics which you have. With this, I will end this lecture and discuss the problem solution for the ELECTRE and also the other method of the ELECTRE method accordingly. Thank you very much and have a nice day.